Good morning, everybody. Looking forward to a lot of the interesting sessions. I saw some of them in IoT and a lot of other storage technology areas. So I'm really looking forward, excited to attend some of those. Well, thanks once again, Nitin. To start with, okay, Industrial Revolution 4.0, that's upon us now, and we've been hearing a lot about it. Thanks to a lot of the automation, AI, and just purely the rapid technological innovation that's happening, that's really transforming businesses. And this is largely happening by having a lot of industrial processes and machines becoming smarter and a lot more connected, giving rise to a lot of information to improve how we can actually interact, how these machines interact, how we interact with these machines. So this has led to an explosion, really. Some of these slides, this one particular, in fact, I think in every conference these days, we simply hear about a lot of these numbers. Zettabyte and quintillion bytes of data coming in every day, about 50 billion devices, I heard one of the reports from IDC saying that it'll be added by 2020. So mind-boggling numbers. I don't even know. I think it's about what, 21 zeros I counted for zettabytes. Can't comprehend these numbers, really. But that's the reality. We're looking at a huge amount of data coming from multiple sources. And if you see here, what you're looking at here is the endpoint. This is again from the IDC report, the recent report, which talked about all these endpoints. As Nitin mentioned, we have been actually working very closely with a lot of companies in building and bringing in IoT solutions all the way, really building IoT platforms itself on one end of the spectrum, and building some custom made at that end. And some of the other projects that we're doing involve a lot of data. How we can help these customers store this data? How can we analyze this data? Where should the storage for these all this data that's coming, where should it be residing for all these customers? So a lot of the challenges we're seeing, and we have seen, again, this is just a small set of applications that we're seeing. In fact, I was just to point out the agriculture one, I was really very surprised. In India, apparently paddy cultivation also is happening by drip irrigation. Very, very surprising for me. But there are companies actually today, goes without saying, I think an Israeli-based company, which is actually bringing in IoT technology to help with the drip irrigation, and it's apparently, in fact, in Maharashtra as well as in some farms in Karnataka. So as diverse as agriculture, connected cars, we are working closely with an OEM. We're bringing some of these technologies to help with connected cars involving the networking and bringing in all these SDN, SDS solutions to bear to the solutions, to bear to these problems. So a lot of these things that we're seeing today is really contributing to a huge amount of data on a day-to-day basis. So the question is, what is this data? We're talking so much about all this data. Well, simply put, it's largely time series data. Most of it is. We are actually, these sensors that people are producing, it's going to be put on these devices, which is going to start getting all this data. So apart from the data of these systems which are getting monitored, there's another one that is about these systems itself, these sensors itself. So imagine, actually, we're going to soon get into this world where with the plethora of sensors around, we will one day see very much like the aircrafts having black boxes. So each of these devices that unto themselves will become black boxes. What I mean by that is, apart from actually getting data of the systems and these processes and everything, what if I want to actually debug or find out? It's bound to happen. Some of these devices may conk out, something may happen. So how do I address this problem? How do I actually figure out where the problem is? Is it really in the network itself, or is it in the sensor itself? How do I figure that out? So we're slowly going to get into a world where each of these devices unto themselves become like something like a black box. So there's a lot of data of these devices itself that needs to be addressed. We need to start thinking about where to store, what do you do about this, and how can we analyze this data. So a lot of forensics and troubleshooting kind of data is also going to be something that we have to start focusing on. So another important thing is, okay, that's about the data. What is so particular about the IoT data? Again, timely and accuracy. This is to say something like, I just cannot, there's a lot of coherency that needs to be thought of and addressed. If I'm getting a lot of this IoT data, and if the data are discrete points, most of the time it's going to be data points which are going to be actually correlated. So if I have a temperature sensor, and if I'm reading a temperature data related to the environment and how that relates to some, let's say, some failures, I need to be able to get both the data points at a particular time. If the data moves across the time boundary, the fixed time boundary, and if I'm not able to correlate, it is meaningless. There's no point in even collecting this data. The amount of jitter that starts coming in, we need to start ensuring that this jitter is minimum. Otherwise, there's no guarantee of how I can interpret this data and what value I can bring in. So not just the timely data, the accuracy, we have to worry about both together to make the data coherent. And that coherence is what needs to be captured. Actionable intelligence, of course, all this is we're collecting just to make sure that we're able to take some actions and come up with some right solutions. I mean, after the insights are gathered, then we should be able to take some corrective actions. This also can be addressed not just by systems, but a lot of times we've seen a good visualization of this data helps get patterns out in the data and the way the systems are working. So visualization is a pretty important aspect of this entire data analysis that we do. Well, knowing what the data is and what the nature of the data is, how it goes through, again, it's a bunch of things that we're looking at in this process. One is, of course, gathering the data. After the data is picked up from the sensors, is ingested into systems. It goes through all the gateways into systems where the data is actually cleansed, transformed, and doing a lot of transformations. We then come up with insights. It goes through a long process here. In this process, the big question is, where should this happen? We have, as diverse as I said, drip irrigation, fine. One of the plants, if it doesn't get enough water, that's maybe okay. I can come back in the next morning and actually give some water, or maybe some other time I can do that. But in systems like mining systems, or companies like all these Schlumbergers of the world and other, they have the systems where I need to actually start controlling the kind of crude that comes out of this pipe, and I need to be able to divert it for the right kind of processing. Now, it's important to make sure that those kind of decisions are taken close to where the action is, where the data originates from. So I can actually do some processing out in the for something to be analyzed and some patterns recognized, and do some planning, long-term planning at that. That's one activity I can do. And the other important activity is to be able to start looking at the data, processing and taking decisions immediately for some value to be brought out. So we are looking at a spectrum of on a scale of time as to where the processing needs to happen. So obviously, when this happens, also the other aspect here is not all the data. Again, this is not everybody will tell you. When we talk about all the data, zettabytes of data and all that is great. But to really be able to come up with something meaningful, not all data is important. That of course actually brings another point. What data needs to be stored and what needs to be discarded, what needs to be retained for short-term purposes, what needs to be retained for long-term purposes. So all these are issues that need to be addressed. That's where storage technologies actually get employed, and the ones that can address these problems today. And there are a lot of systems that are actually being worked upon, cutting-edge technologies which can address some of these problems. We'll talk about that in a minute. So this is where the paradigm of edge computing comes in. So we're looking at data that can, for processing it immediately, close to where the data originates, we have edge. So at the edge, we need some kind of storage, we need some kind of computing ability to be able to take care of everything that I talked about, of processing the data and taking some actions immediately. So that's at the edge level. And for long-term retention, for data analysis, for actually bringing in some planning activity, all this will be done in the cloud. That's, I'm sorry, that's going to happen in the cloud side, yeah. So if that's the case, what kind of storage are we, solutions are we looking at? We're looking at edge, where we need local processing power, you need decision-making ability, and largely it's going to be write intensive. So we need some storage at the edge level, which is going to be fast, which is largely, of course, SSD, which has got low latency. That's one. And not to say that I don't need that kind of a latency, but I can live with a little higher latency, because largely what I'm going to be doing is analysis and long-term planning. So I need storage, but more of it. And more of it obviously means I'm going to pay cost, but that's going to be most effectively done if efficiently used in the cloud. So as we talk about this, some of the challenges that we're seeing, it's not that this is going to be something that is addressed and done and the solutions. There are, by and large, it's a hodgepodge of a lot of different technologies that is brought to bear to these problems. So some of the challenges that we are seeing is, of course, the volume of data. With so many sensors out there, the heterogeneity of data itself is is one problem unto itself. That's one. And the amount that we're looking at is a huge amount of data that we're seeing. The data endowed, that goes to talk about the coherency of data that I was talking about. Unless and until I'm able to correlate the data, two discrete points unto itself may not give me any information. Only when I correlate, I need to have, it makes sense and I can draw some insights and do something about it. So when you have a lot of that kind of data and coming out at a fast clip, that's when you need technology at the edge level, which can address and help you store this and do some analysis on it. So what kind of technologies can we use? So of course, the ones that we have today is something that we are employing for some of these problems. The flexibility and agility that we are seeing with being able to just handle the data that comes across. I need to be, back in those days, some of these complex problems we have seen are when we used to see the satellite coming up on over India. We had a small bandwidth, a small time frame. We actually had to take all the data that was dumped by the satellite, quickly process it, and keep the storage available for the next round of the satellite over India. So that's a kind of agility, but that agility wasn't really to the level of minutes or microseconds. Today, with the kind of IoT device and sensors data that we're seeing, it's at second levels or sometimes sub-second level data that we're seeing. And I have, at the edge, finite amount of storage. So I need to be able to address this problem of when the data comes in, quickly start processing it, take some, bring some insights, do certain things, and then keep that storage free for the next set of data that is coming in. So rapid provisioning of storage will be required. Rapid processing of that data is required. And since it is going to be a lot of write activity, largely going to be the profile of the I/O is going to be something that is important for us to study and come up with what kind of storage. Quick access for being able to do take some action of shutting down valves, or some actuators need to be quickly activated, or whatever action needs to be taken, and move on so that the next set of data can come in. So what kind of storage technologies are we looking at? Despite doing this, we have had a situation where about 40 devices were being, the data coming in was addressed. But slowly, this company that we are building solutions for, it's slowly getting into about, this is in the industrial space, trying to help out improving the production. And we'll be looking at hundreds of such sensors coming out from forge machines and lathe machines and what have you. Quickly, having that one server or one edge server or one edge device taking care of this is not going to address the problem. So we're looking at a set of devices, set of edge devices which are going to start, which I'll need to start employing to be able to address all the data that's coming in. So we're slowly getting into something like the fog computing that these days we're talking about, right? So these are solutions that need to be, again, that is something that can be used to address this problem of how agile we can actually be to start processing the data. Challenge number 3 is it'll be good. Some of these things is, this is not so esoteric. When we're talking about AI and analysis and all these things, we have this problem of storing data at the edge level and all that we talked about, and then long-term data out there. Still, all this is being configured manually to, and again for custom configuration is done. For every implementation, what kind of data I need to store at the edge level and what needs to be stored to the cloud. This is pretty much done manually, can probably be automated a little bit, but again, it's going to be done per deployment, per customer solution. Wouldn't it be great to actually come up with some kind of an engine after having done a lot of analysis to build a generic framework which can take care of this problem automatically in a generic fashion? That's another challenge that we have, where if I can actually come up with some solution, and I invite everybody here to, this is something that Calsoft is trying to help out. How can I actually build a framework that can automatically decide what needs to be stored here, for how long, what processing needs to be done, and what needs to be moved to the cloud? Doing this automatically without, and the first stage of the evolution here is today we're doing all this manually, but can it not be done automatically? There are companies who have started working on it, but we are far away from a good, elegant solution for this. So this is something that, again, Calsoft has, we have really seen a lot of a need for this kind of an architecture. Goes without saying that with all this data, security remains to be a big concern across industries. Different kind of concerns will every enterprise will have. Maybe Nitin, you can add a little bit to the security. Nitin has worked a lot on the security side. Thanks. Some challenges around the networking, on security itself, yeah.
Yeah, so as Vipin mentioned and talked about some of the other IoT case studies, right? The scenarios. There are scenarios like solar farm where electricity is getting generated, right? It's out somewhere where there is very limited physical security that you can provide, right? Now, all of these solar farms, if they are generating, energy for the nation, it becomes a very critical, kind of a system, right? And you don't want anybody else to be able to snoop the data, right? It could be as simple as, replacing that company's own edge device with your own edge device, right? And that way you can snoop everything that's happening in that solar farm, right? So there are a lot of these kind of challenges also, and especially, as I said, because some of these systems will be at the locations where there's absolutely limited security that somebody can provide, right? So there are solutions like TPM. It's not a technical project manager or program manager. TPM is like a platform module, which is the hardware-based solution which resides in every IoT device nowadays, so that nobody can impersonate the device itself. Nobody can snoop the device by saying that, okay, I'm the right device, right? So those kind of innovative security solutions are also coming up, right? Then you always have problem of data encryption and data protection, because you're pushing the data from the factory floor to maybe cloud or maybe to the edge. So you have to encrypt the data. And the data encryption is happening even today as well. But then what's the challenge with the IoT kind of data? As Vipin has been telling, the sensitivity and the dynamism and the latencies, they have to be extremely low, right? So when you have the overheads of encrypting and decrypting the data at the other location or other endpoint, you are impacting that latency. So you need to have the very efficient solutions which are encrypting the data in a way that nobody else can snoop the data, but you still have to have the lower latencies intact. How do you achieve that, right? And we haven't seen any good solution so far. I think that's another area which is still up for the innovation here. And then there are a lot of other regular security concerns, right? Data protection, because the data that you are storing, you also want to make sure that when you're purging the data, you are purging it successfully, and nobody can recover that data again, because a lot of these data can be very sensitive. It could be a missile system data, for example. Missiles by themselves have a lot of these kind of sensors, right? After a year, when you have to purge that data from missile and security kind of establishments, you want to make sure that nobody else can recover the data, even if they get their hands on the storage or the edge devices, right? So a lot of these kind of challenges are there in the IoT workloads.
One, I mean, he talked about missile data and all that. Really coming down to the ground level. I just remembered another situation which was not really it's security, but more of privacy, and dealing with petty politics on the shop floor. That kind of a situation is also something that I was dealing with. I was discussing with this client where on the shop floor, the data related to a set of lathe machines that is managed by the night shift supervisor, one night shift supervisor, needs to not to be shown to another night shift supervisor who was managing another set of machines. So the requirement was, how do you actually keep the information that of the machines coming from the systems that I have been monitoring in my night shift from the guy sitting. Again, this is petty politics playing out in the shop floor. That is another kind of privacy concern. Sometimes we actually see as crazy as that kind of situation is also something that we have come across. But yeah, so privacy, segregation of data, security, these are concerns again that we need to start worrying about. However crazy sometimes this sound, but people do have some of these requirements. Well, so all these challenges that we talked about, of course, they also pose opportunities. The challenge that are posed by all this data means that we have some opportunities also looking at our face. So these opportunities is something that we have seen and worked on in multiple of the engagements, bringing in IoT solutions and helping customers adopt IoT solutions. So some of these again goes to all the points that we've talked about, but I would like to actually invite extend this invitation to anybody who is working in this area, has solutions or has thoughts around how these can be brought to bear to some of these problems that we're seeing. Would really love to work with all of you. Some of these solutions we have created some of these specifically for some customers. But I think as an industry, it's time for us to start thinking about some generic solutions, generic framework. And another thing, Udayan right in the beginning mentioned about standards. This is another area, again, security. Standards around storing of data, standards around how we can actually decide where the data can be. Some of these things is completely, literally like a Wild West situation we have here. So it will be good to actually start seeing some of these members from all these companies with people around here in this room. I would really like to invite all of you to start collaborating and seeing how we can collectively come up with some solutions to address some of these challenges. As I said, some of these challenges are already being addressed by hodgepodge solutions, but some standards that we can come up with, some frameworks that we can build is the need of the hour here going forward.
Yeah. And while we have come across a lot of these kind of problems and we have tried to take care of those problems, but I'm sure there are a lot many others which we haven't seen. And if you guys have seen any such issues, we would love to collaborate with you. We'll love to hear your problem statements and do a common or joint brainstorming on how we can solve those kind of issues. Thanks a lot.
Thanks a lot. I think we are up for on the time side, but maybe a minute or two if anybody has any questions.
Just such an interesting topic that we couldn't fit it in.
I mean, I know we quickly had to breeze through this, but it is something that on a day-to-day basis, we are seeing a lot of challenges. And that's why we just wanted to come up here and share some of these thoughts with all of you. But any questions, anybody? Nope. Okay, probably this is not what people are interested. Really, the important workload of today is what people is looking forward to, elections.
We'll be here for next till tomorrow as well. So if you have any questions related to our experience and what problems we have faced and how we have solved, both Vipin and I, along with our architects, we are here. We have a booth here named CalSoft, and there are a couple of interesting demos that we have put up there. There's also an interesting game where you can play and win some goodies from CalSoft. So thanks a lot. Thanks, Vipin.
Thank you very much. Thanks Nathan,
Paul
for helping
and
out with this, and
for giving us this opportunity.
Yep, thanks everybody. Looking forward to hearing and attending all the sessions. Thank you.